All right, section 8.2, circumference of a circle. So we have some definitions to deal with. And the first one up is circumference. What is the circumference of a circle? So the circumference of a circle is the distance all the way around the circle. It's usually represented by the letter C. Another word that you may be able to relate this to is the perimeter. So the perimeter of a circle has a special name. It's called a circumference. Another definition is pi. This isn't something that you can eat. It's just pi. There's no e on the end. And we consider it to be a constant value, which means it doesn't change. And as a shorthand in mathematics, we use a symbol to represent pi. And that is this symbol right here. Now that's what it looks like when a computer prints it out. If you're going by my handwriting, this is kind of how I usually draw my version of pi. It's very similar. And it's approximately equal to 3.14. Now, it's a special number. It seems to go on forever without repeating, as in there's a bunch of numbers that come after the 4. And some people have actually memorized it to 100 digits and probably beyond that as well. But 3.14 is close enough to what we are going to do here in our math class. If you were a physicist out there in the real world and you're dealing with large scale circles, perhaps circular orbits of planets or something like that, maybe you might need a little bit more accuracy than that, but for our purposes 3.14 is what we're going to use. So we've got an example here, and we've got this circle, and it has a diameter of 5.2 centimeters. So from the outside right through the middle all the way to the other side is 5.2 centimeters. We're being asked to estimate the circumference of the circle. So find out what the distance is all the way around this circle when all we know is the diameter. And then we're going to calculate it as well. So we're going to estimate first, then calculate, and we're going to round our answer to 1 decimal place or to the nearest tenth. So when estimating a circumference, we're going to start by looking at the formula for circumference. Circumference is equal to pi, or 3.14, times d, the diameter. So when estimating, well, 3.14 is actually very close to 3. And in this case, 5.2 centimeters is also very close to 5. So we can estimate, we can just do that quickly in our head. Well, pi is close to 3, 5.2 is close to 5, so 3 times 5 gives us a quick, fast answer of 15 centimeters. So we're estimating that the distance around this particular circle is 15 centimeters. Now clearly this is not to scale on this diagram, on paper at least. This is closer to about 2 centimeters across, not the 15 or not the 5.2. If you were to draw it to scale, then you would see quite quickly that, oh, well, maybe 15 centimeters is pretty close. So that's our estimate. So we're going to now calculate it using the specific numbers we've been given and see how close we get. So instead of pi, we're going to use, or instead of the symbol for pi, we're going to use the numbers 3.14. And instead of d for diameter, we're going to substitute in 5.2 centimeters. Don't forget your units when you're working with this stuff. So when you punch that into your calculator, you're going to get the answer of 16.328, and in this case it's centimeters. So it's actually 16.328 centimeters all the way around the circle for the circumference. Now we were told to go to 1 decimal place or to the nearest tenth. So we're going to look at the second digit. It's a 2, so we don't have to increase this 3. We can just drop the 28 off the end, and now 16.3 centimeters is to the nearest tenth or 1 decimal place. So now that we've got our calculation and our estimate, we can compare them. They're close together, 15 and 16.3. That's basically the same ballpark scale-wise of numbers. It's not like it's 15 and If you made a mistake, you might have put in 163 centimeters. That would be a red flag that you've got the decimal in the wrong spot. Or if you had 1.63 centimeters, again, might be an indicator that you've got the wrong decimal place. So that's why estimating can be useful, just in placing your decimal place even. So the answers are close, but they're not the same because one is an estimate, which is not exact, and then one is a calculation, which it says here is exact, but if you do notice we're using the approximately equal to sign. This is more exact than our estimate, obviously, but the reason for the approximately equals to sign is because pi. Using 3.14 is not exact, but in our case it's close enough. In most cases, I'm not going to lose any sleep if you use the approximately equal to sign or the actual equal to sign when you're using 3.14. We'll just assume that we're using approximate values of pi, because truly we don't have a specific accurate version of pi that we can use that is going to be perfect. So we're dealing with imperfect circles, I guess you could say. And so that is that. Next up is a show you know. Give it a go.